Good morning, students. In the previous video, we were discussing the uh, try yourself questions of the work energy power from question number 1 to question number 21. So now we will continue with question number 22. One man takes 1 minute to raise a box of 1 meter and another man takes half minutes to do so. The energy of the two is in previous one of the problem we have discussed already. So the work done or energy work done does not depends on the work done does not depend on the time. When work done does not depends on the time, even the energy also does not depend on the time, because whatever the work is done, that is appeared in the form of energy. So therefore in both the cases energy will be same, because same work is done, therefore same energy will be stored. So energy is same in both the cases. Next, question number 23. From a waterfall, water is falling down at a rate of 100 kg per second on the blades of turbine. If the height of the fall is 100 meter, then power delivered to the turbine is approximately equal to. So what is the expression for power? Power is equal to work done divided by time or energy divided by time. Energy is gravitational potential energy, mgh, divided by time. So mass is 100 kg per second and g is taken as 10 and h is 100 meter again per second they only have given. So therefore time is 1 second. It becomes 100. So 2, 3, 4, 5, 10 to the power of 5 watt is the correct answer. But they have given the answer in terms of kilowatt. Therefore 100 kilowatt is the correct answer. So A is the correct option. Go to question number 24. This is also almost the same kind like the problem number 23. The power of pump which can pump 200 kg of water to a height of 50 meter in 10 seconds will be. So what is the expression for power is equal to work done divided by time. Work done is okay. Work done divided by time. Work done, due to that work done, here potential energy is increased divided by time. So mass is 200 kg, G is 10, H is 50, divided by in 10 seconds it is 10. So it becomes, that is 5 2 that, or 10, 10 into 10 to the power of 3 watt or 10 kilowatt. So A is the correct option for question number 24. Next, go to question number 25. When a spring is stretched by distance x, it exerts a force F is equal to minus 5x minus 16x cube Newton. Work done when the spring is stretched from 0.1 meter to 0.2 meter is. So first basic idea, this expression they have given F is equal to this expression. So in that expression, I will take x as a common factor, that is minus, or okay, I will take minus also as a common factor. The left thing is 5 plus 16x square into x Newton, and compare this with the standard form of equation f is equal to minus kx. So when you compare with the f is equal to minus kx, minus minus, so in place of k what is there? K is equal to 5 plus 16x square. So this is what the value of k we have. So now we need to find the work done. What is the formula for work done? Work done is equal to change in kinetic energy or change in potential energy according to work energy theorem. That is of k x2 square minus of k x1 square. So substitute the values. Here x1 is equal to 0.1 meter and x2 is equal to 0.2 meter. So therefore W is equal to of k is this is 1 5 plus 16x square, 5 plus 16, x is 0.1 the whole square into x, oh sorry, this is 0.2, 0.2 square into x2 square, x2 is again 0.2 square, one more 0.2 square, minus of k, 5 plus 16 into 0.1 square into 0.1 the whole square. So now after simplification, we will get the value, that is 8.7 into 10 to the power of minus 2 joules. So but the answer is not there. 8.7 10 to the power of minus 1 joule is there. It is not minus 1, it is minus 2. So if you make this as minus 2, in option C, This is the correct option. So C is the correct option. Next, go to question number 26. A body of mass 2 kg is projected at 20 meter per second at an angle of 60 degree above the horizontal. Power due to gravitational force at a highest point is, calculate the velocity at the highest point. The horizontal velocity Vx is equal to V cos theta. So there is nothing but V is 20 cos 60. It becomes 1 by 2 means 10 meter per second. Let us calculate the power. Before that, what is the angle between the horizontal velocity and gravitational force? Horizontal velocity and gravitational force. Angle between them 90. What is the formula for power? Power is equal to F V cos theta. F dot V or F V cos theta. F keep it as it is. V also, F is nothing but mg. Okay, just a minute. So F can be written as mg into V into theta is cos 90. Cos 90 is 0. 0 into something 0. Power will be 0. So 0 is the correct option. That's option D. Next, go to question number 27. If you throw a body upward with velocity 4 meter per second, then at what height does its kinetic energy reduces to half the initial value? So that is, according to law of conservation of energy, when the body is thrown up, half of its kinetic energy should reduce, and it, as usual, it will convert into potential energy. So I can write half mv square, because half of this kinetic energy is converted into potential energy, that is nothing but mgh. So mm get cancelled. I want an expression for h. So I want to calculate h. H is equal to g will comes here, that is a v square divided by 4g. V is 4, 4 square is 16, divided by 4 times of G is 10, they have given. So 4 ones are 4 fours are, so there is H is equal to 0.4 meter. That is, A is the correct option. Next, go to question number 28. A ball of mass 2 kg and another ball of mass 4 kg are dropped together from a 60 feet building. After a fall of 30 feet each towards the earth, the respective kinetic energies will be in the ratio of, what is the formula for kinetic energy? Kinetic energy is equal to half mv square. So here one important point, my dear students, velocity will be constant. That's an important point. After reaching traveling a 30 feet, its velocity is constant. That is a key point here, because when the two objects are dropped at different height or having different mass, they reach the earth in the absence of air. They reach the earth at the exact time or at the same time. Means the velocity is constant in both the cases after traveling a 30 feet distance. So kinetic energy mainly depends only on the mass then. That is, kinetic energy is directly proportional to mass. So I can write kinetic energy 1 m1, kinetic energy 2 proportional to m2. What we want here? The ratio. So kinetic energy 1 divided by kinetic energy 2 is equal to m1 by m2. It will be 2 by 4, nothing but 1 by 2. So 1 by 2 means 1 is to 2. So B is the correct option. Next, go to question number 29. Two springs A and B having spring constant Ka and Kb, Ka is equal to 2 times of Kb, are stretched by applying a force of equal magnitude. If energy stored in spring A is Ea, energy stored in B will be. So here one important thing, force is same, force of equal magnitude. This is a key point again here, my dear students. So I need to write the expression for EB. So before that, what is the expression? E is equal to, or we can write U is equal to half kx square, or this is also okay, half kx square. But they did not say anything about x. That's why let me write the expression in terms of force. This expression, we know this expression, F is equal to kx. Or I can write x is equal to F by k. So this equation takes the form E is equal to half into k into x is replaced by F by k the whole square. Then this equation takes the form E is equal to 1k cancel, that is F square divided by 2k. So again F is constant, they only have given that variable is only k. Therefore I can write EB divided by EA is equal to 1 by KB into Ka. They have given Ka is 2 times of Kb here. So 2 times of Kb divided by Kb cancel, 2 is the left thing, or I can write Ea is equal to 2 times of Eb. Eb is equal to 2 times of Ea. So which is the correct option? C is the correct option for question number 29. Go to question number 30. A body is thrown vertically up with a certain initial velocity. The potential and kinetic energies of the body are equal at a certain height at a point P in its path. If the same body is thrown with double the velocity upward, the ratio of potential and kinetic